welcome back to the conclusion of the inequalities unit. Today we're going to be talking about solutions to inequalities, but I will not be the one presenting to you about solutions to inequalities. Today we're going to have a guest presentation by Miss Scott. So let's go ahead and get started with that right now.
Today we're going to talk about identifying solutions to inequalities. Please follow along in your packet as we complete the video together. We will now look at the first slide. Let's take a look at what is a solution to an inequality. A solution is any value that makes the inequality true. Or some people think of it as any value that works in an inequality. Now, there's a difference between solutions to an equation, which we've already talked about, and solutions to inequalities. Most equations have only one solution, but inequalities actually have many solutions. So take a look here at the bottom. For example, in the equation x equals 3, the only value that x can be is 3. However, in an inequality like x is less than 3, there are many different values that x could be. So for example, x could be 2 or 0 or negative 100 or even 2.994 because all of those are less than 3. Let's take a look at a problem together. Example A. Circle all of the values that are solutions to the inequality. When we're talking about solutions and inequalities, we have a couple different options. We could substitute all these different values into the inequality and see which ones make the inequality true or which one makes it work. But we also could solve the inequality and then verify which solutions meet that description. So those are the two options we have in any problem. In this particular situation, trying to substitute all of these into the inequality would be very time-consuming. So a more efficient way would be to solve it and then verify which solutions match that description. So to solve it, we'll begin by adding 7 to both sides of the inequality. When we do that, we get x over 2 is less than 3. Now our next step will be to multiply both sides by 2. I'm multiplying by a positive, so no need to change the sign. And my solution will be x is less than 6. So now I need to go down here to the box of possible answers and choose all of the values that are less than 6. So certainly I could pick negative 8, negative 5, 1, 3. Now I have to decide, should I pick 6? Well, if x is less than 6, then x cannot be 6, nor can it be any of these numbers bigger than that. So our solutions to this inequality are negative 8, negative 5, 1, and 3. All right, let's take a look at the next problem. Example B. Circle all of the values that are solutions to the inequality. Well, once again, I have a choice. I could substitute all of these values into the inequality and see which ones work or which ones make the inequality true. Or I could solve this inequality and then check which ones match that description. I'm going to go with the second choice. It seems more efficient. So I'm going to begin by subtracting 15 from each side to eliminate this constant value. I bring down negative 10n less than or equal to negative 90. Inequality symbol stays the same because I've only subtracted. Now I need to take a look at this here. And I see that I have to divide both sides by a negative 10. Of course, once I do that, I will flip the inequality symbol, and I will get n is greater than or equal to 9. So now I have to pick all of the values that are greater than or equal to 9. So certainly that would be 80 and 22 and 14. Should I pick 9 this time? Well, since it's n is greater than or equal to 9, I would select 9 because 9 is equal to 9. So the values that are solutions to this inequality are 9, 14, 22, and 80. All right, let's take a look at the next slide together. This is a practice one. You're going to try this one. Circle all of the values that are solutions to the inequality. Go ahead and try this problem on your own. Please pause the video while you do the work and then resume the video when you are ready to check your answer. When I solved this problem, I got that y is greater than or equal to -5. So when I choose my solutions, I need to pick all of the values that are greater than or equal to -5. So I will pick -5, -4, -1, 2, 6, and 9. All of those are greater than -5. You could also think of it, greater than or equal to -5. You could also think of it as that all of them are to the right of -5 on the number line. Okay, when you're ready, go on to the next slide. Here are 2 more practice problems for you to try on your own. Please pause the video while you complete practice 2 and practice 3. Be careful, these are multiple choice questions. There will only be one correct answer. When you solve practice number 2, you see that x is less than 7. There is only one choice that is less than 7, so the correct answer is A. When you solve practice number 3, you see that y is greater than -24. Did you remember to switch the inequality symbol when you multiplied by -12? So I look at my choices, and there's only one option that would be greater than -24, and that's -23. So my correct answer to practice number 3 is D. All right, let's take a look at the next slide. Example C. Circle all sets that match this description. All values in the set are solutions to the inequality. So here's another situation we have to choose. Do we want to substitute all of these different values into the inequality and see which ones work? Or would we rather just solve and then pick the sets that match the description? It seems more efficient to solve this inequality and match the sets. Okay, we're going to begin by subtracting 6 from both sides. That will eliminate this constant, and I'm left with -3a on the right and 45 on the left. My inequality symbol has not changed yet. However, now I'm going to divide both sides by -3. And when I do that, I have to switch the inequality symbol. And I see now that a is greater than or equal to -15. So I will select a set if all of the values in the set are greater than or equal to -15. This one would not work. These are all less than or equal to. The next one in this top row wouldn't work either. -17 doesn't work even though the other two. But if even one number doesn't work, then the whole set is wrong. Now in this one, I have -15, -1, and 6. All of these are greater than or equal to -15, so I can select this set. When I look at 3, that should be a comma, 7 and 10, I see that all of those are greater than -15 as well. So let's pick it. Now look at practice number 4. You will complete this problem on your own. Please pause the video as you solve this problem and then resume when you're ready to check your answer. In this problem, we see that f is less than or equal to negative 11. So we have to pick all sets that have, we have to pick a set if all of the values are less than or equal to negative 11. So these are the sets we would choose. Please check your work. We can choose this set right here because negative 11 is less than or equal to negative 11. In this set, 2 of the values do not work. In this set, none of the values work. Same thing for this first set. In example D, we must circle all inequalities for which 6 is a solution. So once again, we have a choice. We could substitute 6 into each of these inequalities and see which ones are true or which ones work. Or we could solve each inequality to see if to see if 6 matches the description for x. It seems like it'd be very time-consuming to solve all of these inequalities, so we are going to substitute 6 into the inequality and see if it works. So in this first one, we'll do 2, and we will replace x with 6 minus 7, and we want to see if that is less than 9. So we're going to use order of operations here. 12 minus 7, is that less than 9? 12 minus 7 is 5. Is 5 less than 9? Yes, that's true, so this is a correct answer. Now let's take a look over here. We will substitute 6 in for x again. So we have 5 times 6 minus 12 is greater than 18. We'll use order of operations. This multiplies to 30. 30 minus 12 is greater than 18. Well, let's see. When I do 30 minus 12, I get 18. Is 18 greater than 18? No, that's not true. So it is not a solution to this inequality. Okay, let's look at the bottom row. I again will replace x with a 6. And I have 6 divided by 2 minus 7 is greater than or equal to negative 2. So when I do this division, I get 3 minus 7 is greater than or equal to negative 2. And when I subtract, I now get negative 4 is greater than or equal to negative 2. No, that is not true. Negative 4 is less than that. So we will cross this out because 6 is not a solution to this inequality. Now we will substitute 6 into this last inequality. We have 6 over 6 plus 3 is less than or equal to 4. Well, let's find out. 6 divided by 6 is 1. 1 plus 3, is that less than or equal to 4? Well, when we add this, we will come up with 4 is less than or equal to 4. Oh, that's true. 4 is less than or equal to 4. All right, so we can circle this one. Now, some people ask, what was the difference between this example up here and this example down here? Well, in this one, it just says 18 is greater than 18. That's not true. They're actually equal. This one says 4 is less than or equal to 4. Since it has that or equal part, then it makes it a solution. So we have 2 inequalities for which 6 is a solution. Now let's take a look at the next slide. You will do this problem on your own. Please pause the video as you determine which inequalities have 12 as a solution. You may resume the video when you're ready to check your answer. If you substitute 12 into each inequality, you can check and see if it is a solution. we see that only 2 of these ended up being true statements at the end, and those are the 2 that are correct. So 12 is a solution to these 2 inequalities. Example E. Circle all inequalities for which -3, 1, and 6 is a solution set. So just like every other problem, I have an option. I could substitute each of these numbers in the set into every single one of these inequalities and make sure all of the numbers in the set work. Or I could solve each inequality and see if this set matches the description. I'm going to choose the second one. It seems more efficient to me. So in this first inequality, I need to subtract 3 from both sides. And I get 4x is greater than -12. I divide by 4 on both sides. And I get x is greater than -3. So is this solution set have numbers that are only greater than 3? No, that's not true. -3 is a choice of the solution set, so that's not going to work. Okay, in the second inequality, I begin by adding 18 to both sides. When I do that, I get 8x is less than or equal to 48. I divide both sides by 8, and I get x is less than or equal to 6. So, are all numbers in the solution set less than or equal to 6? Yes, they are. So that means this inequality is one of the correct answers. Okay, in the last inequality, I subtract 3 from both sides. And I get -2 is greater than or equal to -2x. Now I'm going to divide both sides by -2. Oh no, I've divided by a negative, so I need to switch the inequality symbol. And I get x is greater than or equal to 1. Are all numbers in the solution set greater than or equal to 1? No, that's not true. So this is not a solution. Now let's take a look at the next problem. You are going to complete the 3 independent practice problems on your own. The answers will not be in the video. When you have completed these slides, you will take your paper to your teacher to have your answers checked by him or her. Thank you for watching our video. Have a great day.
Thank you for watching that video on inequalities. If you like this video, go ahead and throw us a thumbs up. If you love this video, go ahead and sub. Otherwise, we will catch you in the next one.